All right, we're going to go over part 2 of this video. 6 through 9 is talking about solving. Really what we're doing here is trying to find the x values. Finding the x values in terms of if the parabola crosses the x-axis or not, one solution, two solutions, or no real solutions. So we have taking the root, we have factoring, and we have completing the square. So we have those things, and so what I'm going to do, quadratic formula. Anyways, we're going to choose one of these methods to go ahead and do this, and we're going to justify why we use that method. Number 6, we're going to use taking the root because we just have x squared. All we do is take the root, and this becomes x equals square root of -1 times square root of 36. Square root of -1 is going to be I, so the answer is going to be x equals plus or minus 6i. There we go. All right. Over here, same thing. We have x squared plus 6 equals -14. This is going to be x squared equals -20. Take the square root, and we get x equals -1 times times 4 times 5. There's a perfect square in 4, so then x equals 2i to the square root of 5. So plus or minus 2i times 5. That's how we do that. Down here, we can't take the root. We're going to try to factor. Let's see if we can factor. We can't factor because there's no multiples of 13, factors of 13 that add up to be my middle term. So we're going to use the quadratic formula. So again, I got my quadratic formula. If you don't remember how to use quadratic formula, remember that's going to be x equals -b plus or minus 2a minus 4ac divided by 2a. And then what's my a? My a is going to be 1, my b is going to be -4, and my c is going to be 13. So what happens there, I plugged in my b for my b, I plugged in my a for my a, and I got this right here. Now, let's go ahead and see if we can simplify this. So we have 4 on the outside, right? Because negative times negative, positive 4, plus or minus 16 minus 4. -4 times 1 is -4. -4 times 13 is going to be 52. So we have -52 all divided by 2. Let's keep going here. 16 minus 52 is going to be -36. So we have 4 on the outside still, plus or minus -36 divided by 2a, or 2. This turns into plus or minus 4, 6i divided by 2. We got 6i because there's a negative there. We get 6i. And again, if you want, we can say this. We can say, do a little math. You want to do a little cameo?
Are you live?
Yeah, you want to do a little cameo? Say hello to the students.
Hello, my students. Nice. You have a Bunsen burner in there? Are they up here still?
Yeah, the small portable ones? Yeah,
Yeah,
for sure. So then, again, this is going to be the same thing as -1 times square root of 36. Square root of -1 is going to be I. Square root of 36 is going to be 6. So we have this, so we got to simplify that, and when we simplify that, we get x equals 2 plus 3i, and x equals 2 minus 3. So 2 imaginary complex numbers. So in this case, the parabola does not cross the x-axis, and there we are. Let's go ahead and do the next ones. I'm doing a video for the practice quiz.
Awesome. Algebra 2?
Geometry.
Geometry?
No, it's like, they'll see this in Algebra 2 as well, for sure.
Yeah. I was going to say, it looks more like Algebra 2, that they keep integrating everything, so it's good.
Now we're going to do systems of nonlinear equations. So I didn't do the last one on the last part because it's quadratic formula and I want to keep this video short, but you would do the same thing on that problem number 10, as you would use the quadratic formula if you couldn't factor or complete the square. Number 11, we're going to solve by substitution, meaning that I'm going to set y equal to y, which means I need to set y. This is already set, right? So you already have y equals on one side. This equation is not though, so we got to set it in a different way. We're going to say y equals, I'm going to add both sides by 2x squared. These cancel, and so you get left with 2x squared plus 1. So we have two equations, equation 1 and 2. And by substitution means I'm going to go set y equal to y, which means I'm going to set 2x squared plus 1 equals plus 3. Now I have to go ahead and expand this. So when I expand this, it turns into x minus 1 squared, x minus 1 times x minus 1 plus 3. And over here I still have 2x squared plus 1. Here I'm going to FOIL. So I'm going to get x squared. I'm going to have minus x. I'm going to have minus x. And I'm going to have plus 1, then plus the 3. So this turns into x squared minus 2x plus 4. On this side I have 2x squared plus 1. Okay. So now what I want to get in standard form. Again, standard form is here. Okay. So once we're there, then we got to decide if we're going to take the root, if we're going to use the quadratic formula, if we're going to complete the square, all those things. But first we got to be in standard form. So what I'm going to do is I'm going to move this over here. So I'm going to subtract both sides by 2x squared. I'm going to subtract by 1. So minus 2x squared there. And then minus 1 over here. So then I get 0 equals negative x squared minus 2x plus 3. So then once we're here, then we can make the decision to go ahead and factor blah blah. And so what I'm going to do is I'm going to try to factor. Let's say here. Now the way factoring works is this, we're going to do the box method. It's been a while ago since we factored, so we're going to go ahead and see this. So what goes here and here is going to be my leading term, which is going to be x squared. What goes over here is going to be my last term, which is going to be 3. I'm trying to find what goes here and here. What goes here and here is going to be my AC. Remember, my AC is going to be A times my C. So negative 1 times 3 is going to be negative 3. Then we find out what are the multiples, what are the factors of negative 3 that add up to be negative 2. So we have two choices. The way we get negative 3 is either we multiply negative 1 times 3 or 1 times negative 3. And we choose which one of these, when we add them, gives us negative 2x. And so it's going to be this one here. So I'm going to choose 1x there, and I'm going to choose negative 3x there. Okay. Now we've got to find out the outside terms. The outside terms is going to be x, and x gives us x squared. Which one is negative? We have to look at the 3 and the 1x, 3x, and 1x. Which one has to be negative? And you would see that it has to be this one. This one has to be the negative x. Negative x times what is negative 3x? it has to be a positive 3. Negative x times positive 3 is negative 3x. What times x is x? Well, 1. Because 1 times anything is just its original term. Then 1 times 3 is 3. So this checks out. So now the factors are here. X plus 3, x negative x plus 1. Negative x plus 1. So now this is set equal to 0. Okay? If this is set equal to 0, what we have here is we go ahead and do the ZPP, the zero product property, meaning that we have x is going to be equal to negative 3, and then x is going to equal to minus 1, so a positive 1. So we have both x values. Now, usually we would be done here, but we're not looking for the exact x values. We're looking for the points. So x values are part of the answer, but not the whole answer. We're looking for actual points. And to have an actual point, you need a y value. So here comes the second part, where now we choose which equation we're going to plug in my information into. Which equation is easier to deal with? Y equals x minus 1 squared parentheses plus 3, or the second one. I'm going to use the second one. I'm going to say y equals 2 negative 3 squared plus 1, and y equals 2. My other x value is going to be 1 squared plus 1. So for this one here, this gives me 9 squared times 2 is 18. 18 plus 1 is 19. Okay, so my first point is going to be negative 3 and 19. My second point is going to be 1 squared is going to be 1. 1 times 2 is going to be 2. 2 plus 1 is going to be 3. So my second point is going to be 1 and 3. So that's my answer for number 11. It's a lot of work because we have solving for x, right? We have factoring, and then we plug our values back into the original equation, and then we have the actual points. And again, you can always use Desmos to go and check your work. This one has no solution, I believe, and so there we are. I hope these videos are helpful.